So in this lecture, we are going to discuss about the economic considerations in vacuum tower design. So economic means it is related with the pressure of the vacuum tower, because we know that the pressure in the vacuum tower is very low and you have to maintain that pressure using the well standard method that will be discussed, that is a steam ejector. So the big question is to solve the optimum operating pressure of the system. How to maintain that one? So that will be discussed here. Before going to that one, that is a very common thing. We all know that if we are going to lower the hydrocarbon partial pressure in the vacuum tower, in the flash zone, so what happens if you lower the pressure of any system? Obviously more vapor will be formed, so the vapor will be increases. If you lower the pressure in the flash zone, so vaporizations will be increases, and hence distillate production is more. So what it means? It means that we have to maintain a very low pressure in the flash zone so that we can have maximum amount of the distillate in that flash zone. Okay, so that is the important thing, that is our target. So we have to think about the pressure in the system so that we have more and more amount of the vapor. That is our objective, to maximize the distillate production. How we can do it? So for example, let us take an example. This is a column where we are going to giving the feed, that is a atmospheric residue, and at the flash zone at the top there is a steam ejector, and that steam ejector is maintained by the top steam, or the steam required. That can be say that that can be a top steam. That name is simply a top steam because there are one more application of one more steam at one more section, at one more location in the column, that is the bottom steam. So if you see that there is a one top steam, this top steam is used for the steam ejector, and the bottom steam, that bottom steam have their own application. But let us discuss about the top steam. So to maintain the pressure inside the column, and that pressure is because of the steam ejector, we all know, and this steam ejector is functioning or maintaining the pressure because of the top steam. If you are increasing more and more steam, then you can lower the pressure in this system. So overall we have to know that the pressure inside the column is maintained by the top steam. That is the important thing. So there is a relation from the top steam and the pressure. So if steam amount is more, what happen? It means that pressure will be very less in the column. So this is a relation between the column pressure or system pressure and the top steam. Now come to the discuss about these are the basically the economic considerations. What it means, if suppose we are going to fix the vaporization in the flash zone, then what happen? So raising the system pressure that is in the flash zone, raising the system pressure increases the steam requirements and also increases the top tower cross sectional area. What it means, let us discuss. For example, if suppose we want to vaporize 45 volume percent of the feed in the column, so for that thing we have to maintain that pressure and temperature. Now come to the temperature pressure point of view. What happen if we increase the pressure is increases? What happen? Then there will be a loss in the vaporization. So now this 45 will be low. For example, it will be a 42 volume percent. If we increase the pressure, and what happened? There will be a low vaporization. And how that pressure can be increased? This pressure can be increasing simply by decreasing the steam, top steam. If you decrease the top steam, system pressure will be increases, and obviously there will be a low vaporization. Say for example 42 volume percent. But as I already told you that you have to fix the vaporization. This means I need 45 volume percent vaporization, whatever may be the pressure. So what we can do? We can increasing the vapor from 42 to 45 volume percent. There is a bottom steam requirement, that bottom steam demand will be increases here. We need more and more bottom steam. This bottom steam is basically strip out more and more materials from the residue to maintain the total vapor into the 45 volume percent. But what happen if you increase the bottom steam? That bottom steam will be available in the tower, that will be available in the column. It means there will be a vapor, hydrocarbon vapors, as well as steam in the form of vapors. So it means there's more vapor in the tower, and if more vapors are in the tower, so to accommodate that vapors, we need a bigger size of tower, that is a more diameter will be increases. So that is a thing that is given here in the first sentence, that raising the system pressure increases the steam requirements, that is the bottom steam requirements, and also increases the tower cross sectional area requirements. So that is the first case when we are going to raise the pressure, because that is desirable, we cannot maintain a very low pressure. So in short, we can write the whole things, all these words in this symbol. If system pressure increases, it means system steam, that is the top will be decreases, but the steam in the bottom will be increases, and it means that tower diameter will be increases. So this is for the case of when we are increasing the pressure. Now come the second one, when we are lowering the system pressure. What it means? It means you are controlling the system pressure by the steam jet ejectors. It means you are increasing the steam at the top. That's simple meaning. Means if you are decreasing the system pressure, top steam requirement increases, but bottom steam is not desirable, because 45% is achieved simply by lowering the pressure with the help of top steam. So there is no need of bottom steam, or very small requirement of bottom steam is there. So that is basically in this case top steam is more and more required. So that is the economic considerations. But there is a one situations, if you lower the pressure at a very low pressure, it is theoretically possible that no bottom steam is required. What it means that now the vacuum tower can be run on the dry mode or dry basis. Dry basis means no bottom steam is required, because all the vaporization of the hydrocarbon is fulfilled by the system pressure itself. There is no need to put the bottom steam for the more vaporization. So that called the dry one. So dry vacuum tower means no bottom steam, and wet vacuum tower means bottom steam is there. So this is the case for the lower system pressure. So we have discussed about two extreme conditions. One extreme condition is when we are increasing the pressure, system pressure, at that time bottom steam is more required. But if you are decreasing system pressure, at that time top steam is more required. So we have to optimize, and that is nothing but the economic considerations. So you have to note down that steam to a bottom tower is for the primary purpose of reducing the hydrocarbon partial pressure in the flash zone. So the bottom steam that is we are going to use, their main purpose is to reduce the pressure, hydrocarbon partial pressure in the flash zone. But at the same time there is one secondary applications, and that secondary application is the stripping of the bottom residue. But that is not the main purpose. So for that thing we need to put the stripping trays at the bottom section. So this is about the story of the bottom steam. That main purpose is to maintain the hydrocarbon partial pressure, but we can also use that bottom steam for the stripping purposes of the residue. And also there is a optimization case here, because at one condition top steam is more required, at the second condition bottom steam is more required. So we have to find out the optimum pressure at which the total steam uses should be minimum. So it has been studying for different conditions of the pressures and different values of the top and bottom, and it's found that for the practical purposes the minimum possible pressure at the top of the tower should be in the range of 10 mmHg absolute. So if we maintain that pressure at the top of the column, that can be a very optimized pressure, and that can the vacuum can run in an economic way. So this is all about the economic concept in the vacuum tower design. Thank you very much.